you will want to be able to identify lone pairs. So if you're given a nitrogen and it has a negative charge, you need to be able to figure out that it's got two lone pairs. Same thing if you've got a nitrogen that's neutral, it should have one lone pair. And a nitrogen that has a positive charge will have no lone pairs. With oxygens, a negatively charged oxygen will have three lone pairs. A neutral oxygen has two lone pairs, and a positively charged oxygen has a single lone pair. Okay, and it's worthwhile to memorize these. You can figure them out every time by calculating the formal charge, but it's worth the memory space to memorize those. So on these diagrams, we want to draw all the lone pairs. So here we have a neutral oxygen, so it's got two lone pairs. Another neutral oxygen, two lone pairs. Neutral oxygen, two lone pairs, two lone pairs here. This oxygen has a charge, and so we know that it's got three lone pairs. I've got really a place to put them there. Okay, this is a neutral nitrogen. It has a single lone pair. And this nitrogen has no lone pairs. Okay. I talked about this a little bit in class. We will be drawing a lot of three-dimensional figures, and whenever you see a wedge, that means that that molecule, that hydrogen, is coming out toward you. So it's above the piece of paper. If you have a dash, that means that hydrogen is below the paper. A line that's just a line means that that bond is on the paper. So this is a tetrahedral.